Hi, let's talk about centripetal forces. To do this, we will go over some definitions, examples, and a sample calculation. Let's start with definitions. First of all, a force is a push or a pull. Now, forces in physics cause things to happen. For example, they cause accelerations. What is an acceleration? An acceleration is the change in speed or direction of an object. So if an object speeds up, slows down, or very importantly, when looking at uniform circular motion, when it changes direction. Now this ties directly into Newton's first law of motion, which is the law of inertia. The law of inertia says that an object in motion will stay in motion in a straight line at a constant speed unless acted on by an outside unbalanced force. Also says that an object at rest will stay at rest unless acted upon by an outside unbalanced force. So what this means is if you see an object either speeding up, slowing down, or changing direction, regardless if you can see an overt force causing it, there must be a force acting on it to cause that acceleration. Now, when we are talking about circular motion, there are usually two terms that are thrown around. One is centripetal and one is centrifugal. Centripetal means center seeking, and centrifugal means center fleeing. Now I remember the difference between these two because I noticed that centrifugal has an F in it, and so does the word fleeing. So centrifugal is the fleeing force. I also remember it because centrifugal is also a false force. It is not a real force. It only exists in a certain frame of reference. Let's also take a look for just a moment at Newton's second law of motion. Newton's second law says force is equal to mass times acceleration. When we are looking at centripetal forces, we have the mass multiplied by the centripetal acceleration, which we find by the velocity squared divided by the radius. Now this is an important equation. Make sure it's in your notes. So, what makes things turn in circles? We've already established that an object wants to move in a straight line and at a constant speed. If it is changing direction, there must be a force acting on it. Let's take a look at some examples. Let's look at the scenario of a tin can on a string being whirled around the head of some physics student. Now, as our tin can is being whirled about, our tin can is in motion, which means that it would like to be moving in a straight line and at a constant speed. However, it cannot do this. There is tension in this string, which is forcing it to change its direction and follow the circular path. So, what is causing our can to move in a circle? The tension in our string is causing it. So the tension is giving us our centripetal force. Let's look at another scenario, the Earth and the Moon. As the Moon is orbiting around the Earth, the Moon would like to be moving at a straight line and at a constant speed. However, it cannot because there is a force acting between the Moon and the Earth which forces it onto a circular path. What causes this circular path? In this particular case, it's gravity. So gravity is providing for us our centripetal force. One more quick scenario. What about if we have a car going around a corner or going around a curve on a road? What is it that keeps the car from moving ahead in a straight line path, but instead allows it to follow the path of the road? In this particular case, it's the friction acting between the tires and the road. So the friction is providing for us our centripetal force. Now, all forces are not equal. Remember earlier I mentioned that centripetal and centrifugal are different, and that centrifugal is actually a false or a pseudo force. We'll talk about why that is in just a moment. Centripetal forces are real forces. They have an action-reaction pair which can readily be identified. When we're looking at our tin can scenario, we can identify that the can is pulling on the rope and the rope is pulling on the can. Action-reaction pairs, real force. Now if we take a closer look inside this rotating frame of reference, we could see on the very bottom of it, if we had a ladybug that was in the bottom of this can, while it is rotating, our ladybug would be experiencing a force that would feel like it was pulling her to the bottom of the can. Now in reality, this is not a real force. It only exists in a rotating frame of reference. Now, you yourself have experienced this. There have been times, I'm sure, when you have been driving along in a car, and when the car goes around a corner, you feel this force that acts like it's pulling you to the outside of the car. What you are really experiencing is Newton's first law of inertia. Your body is an object in motion that wants to stay in motion in a straight line and at a constant path. When the car turns, your body is still trying to go forward, and since it is trying to go forward, you feel like you are being pulled to the outside edge. Now, that is what we mean when we're talking about a centrifugal force. Remember, centripetal is real, centrifugal only exists in a rotating frame. Let's do a sample problem. We have a car that is traveling along at 2 meters per second around a corner of a curve which has a radius of 25 meters. The car itself is 900 kilograms. Let's go ahead and do our problem set. First of all, what do we know? We know that the mass of our car is equal to 900 kilograms. We know the velocity is 2 meters per second, and we know that the radius is 25 meters. What is our target? What have we been asked to figure out? We want to find out what the centripetal force is. Is there an equation we know? Yes, we do. We'll refer back to Newton's second law of motion and modify it for centripetal acceleration. So mass is equal to velocity squared divided by the radius. Do we have enough information to solve our problem? Yes, we do. So what would our calculation look like? Our calculation would be centripetal force is equal to 900 kilograms multiplied by 2 meters per second squared divided by 25 meters. And this would give us a grand total of 140 newtons. So 140 newtons is the force that is necessary acting between the tires and the road in order to keep our car safely traveling around its circular path. So, what things should you remember? First of all, remember the difference between centripetal and centrifugal. One is center seeking, and the other is center fleeing. One of them is a real force, and the other one is a false force that only exists within a rotating frame of reference. To find the centripetal force, you need the mass, the velocity squared, divided by the radius. I hope this has helped. Have a good day.